Does it really matter what speed your SD card is? I don't know. Hello everyone, Chris here, and all kidding aside, I actually don't know if the speed of your SD card is going to matter that much. I got to thinking in the Prusa Link video, what if I were to use a higher end SD card? Would the Raspberry Pi Zero perform better? Or any Raspberry Pi for that matter? So I set out to test every SD card that I could find around the house. Now, not a lot of these are very high class, some of them are outright garbage. But I thought it would be fun to get a set of numbers just to see how one compared to another. So that's what I did. These are all the SD cards that I found to test around the house. I have several different SanDisk models, different speeds and sizes. I have a Samsung in here, a Kingston. My favorite one of all is the one that just reads 8 GB, so that should be interesting. Not even sure where that came from. I even tested a 128 meg card that came with one of my SKR boards a long time ago, just for fun. Now, all these tests, I used the same adapter, same computer, same process. I wanted to keep it as consistent as possible. Now, I did test a lot of other SD cards, even full-size ones, but for this video, I wanted to take the comparison just to the micro cards, because these are the ones that we're going to be using in things like a Raspberry Pi. For the Raspberry Pi, I went with the original Raspberry Pi Zero W. I didn't really see a need to test the other models. I wanted to see if it would affect the slowest model that I had available. See if it would help improve the performance at all. And it's actually pretty straightforward to test an SD card. There's free software out there that you can run, including some really simple tools, and that's what I used. You really just need to do some writes and then read it back and see how fast it can do that. Now, of course, all of these SD cards have these advertised speeds that you can achieve with that card, but none of them are even close. You're probably not surprised. But let's walk through the steps I took to test all these cards, and then we'll take a look at some data. So to test all the SD cards, I just wanted to know the read and write speeds of each one. We don't even have to use a lot of data. There's a tool available out there for free. It's called H2TestW. It's been around a long time, and it's a really easy way to test something like this. You can test pretty much any device, USB interface, whatever you want with this tool, and it gives good results. So I just mounted up each card, used the disk management tool in Windows, made sure the card was FAT32, it only had one partition, and it was formatted. Then I ran my test. You just select target, go to that card, hit OK, and I'm just going to use 500 meg to test it. And then you hit write and verify. It's going to write out 500 meg, give you the speed that it did that in, and then it's going to read it back and give you that speed. And here's all the information that I recorded. This is one of the quickest cards I tested, but now I'll show you all the data that I collected on a graph, so it's easy to compare them. And here are the stats. You can see there's pretty much a clear winner, this SanDisk Extreme. That's a 32 gig card. They cost around $10 each. The rest of them are a lot more affordable. You can see some of the really low runners here. 8 gig did not do well. Neither did the 128 meg, but I really didn't figure it would. It was kind of disappointing over here all the way on the left, the SanDisk Ultra A1. I use those for a lot of things. It did pretty well compared to the other cards, but I thought it would be a lot better than that. So I might consider changing my selection of SD card up a little bit, because that is my go-to. I might have to find another one. The Extremes are probably just a little bit overkill for what we use them for. One I was kind of interested with was the ADAT 64 gig card all the way on the right. It did a lot better than I thought it would. It was the only 64 gig card. Everything else was 32 or less. So that means that's extended FAT, not just FAT32. Which shouldn't matter. I did test all of these with an NTFS format, and it really didn't affect the speed at all. A lot of these I tested multiple times just to make sure the numbers were somewhat accurate. Again, this is the same adapter, same computer that I ran these tests on for every one of these cards. So at least we have some numbers to go on. So great, you've tested all these SD cards, and one is obviously faster than all the others, but why would you actually care about this? Well, you might care if you're running the Raspberry Pi with an OS that might need a little bit more performance. Say it be OctoPrint, Mainsail, Fluid. anything you wanted to run, just straight up Linux, you might need extra performance out of that SD card, but I really have no proof. So that's what I set out to test next. So to test all of these, I went to OctoPrint, of course. I want to test to see how fast it boots and how fast it will be available, to see if these cards' read and write speeds actually make a difference at all. And we'll test a few other things along the way. But this is how I set the test up. I created a Pi image by starting a new version of OctoPrint on a card, editing it, going through the wizard, and then saving that image off. And then I wrote that same image to every card that I tested. Now I'm not going to go through every card because it's pretty obvious some of these aren't going to perform well, but the higher speed ones, let's see how they compare to some of the lower speed ones. So I've got my Pi test image. I'll choose my storage. This card is the Extreme SanDisk card, the fastest one of the bunch, and I'm just going to hit write. Now, one of the first things you're going to notice about the Extreme card is how fast it actually writes. I timed a lot of these to see how long it would take to get the image written, and this one by far is the best. And that's what you would expect. The write speed is so much better than the rest of the cards. So that might be one advantage that you would like out of one of these higher speed SD cards right off the bat. It's just going to save you a lot of time writing the image. So there is the time for the image write for the Extreme card. And I was a little late clicking the button, but you can see as I test the next card that that's really not going to matter that much. And here we're testing that image write on the next fastest card pretty much. The Samsung might have been a little quicker, but they're pretty close. But this is the one that I use the most often, the SanDisk Ultra, the A1 speed number 10. It is a lot slower than that Extreme card, as you saw in the numbers. And there it is after it's finalized, ready to go. This card is twice as slow as that Extreme card. And I thought we'd go ahead and test one of the slower low-end cards. And I went with this one. I don't even know how you pronounce this. NETAC, whatever it might be. This is the one that I chose to go ahead and test. And this one took almost 7 minutes. It's pretty painful to sit here and watch this write the image. But now we have 3 use cases, high-end, medium, and super low, to test on. And for the tests, all I'm going to do is use the same Raspberry Pi Zero to start out. Remember, that's all the same image, just a different card, and we're going to use the same power supply. I'm going to let it boot up, and then I'm going to perform a restart and time it. And we're ready to start our reboot tests. So what I'm going to do is I'm going to issue a restart on my OctoPrint image. This is our slowest card, so we'll do reboot, and I'm going to start the timer. Now, to check when OctoPrint comes back up, there's a plugin for Chrome that will refresh every couple of seconds. So we're going to do auto refresh. Let's do 20 seconds. We're looking for a big advantage in startup time here. So 20 seconds one way or the other on these cards really isn't going to matter. Booting up like this, you're really just worried about read speed for the most part. We'll do some write tests as well. I don't think it's really going to matter. Maybe with this really low-end card, it won't start as fast, but we'll see how it goes. And for this card, OctoPrint was up and ready at around 4 minutes and 30 seconds. You can see it's still refreshing over there, but I was watching it the whole time. So a respectable time, even for this slow card. Now let's move to the SanDisk A1 card. And OctoPrint is up on the A1 card, so let's go ahead and kick off the reboot, and we'll start our timer. And the A1 card made pretty much no difference. We're still right at 4 minutes 30 seconds, even though it has a lot higher read speed than that last card we tested. But let's go ahead and test the Extreme card as well. And here we go on the Extreme card. We'll kick off our reboot, and again, start the timer. So the Extreme card was just a little bit faster, but not by much. Maybe 15 seconds, but not enough to declare it a winner. So they're pretty much all the same at this point on boot up time. So for the next test, given that all of the write speeds were way off from all the different cards high to low, that's what I wanted to test. So I thought it would just be worthwhile to upload a file and have it write it to the card, and check all 3 of these cards. So we're going to start with the Extreme, the fastest one we have. And I'm just going to upload a sizable G-code file. It's around 250 meg. And we'll just see how long it takes. So on the Extreme card, that 250 meg file took right at 3 minutes to upload. So I'm hoping that it will actually be longer on the slower cards, but we'll see. Most of that is upload time, not just write time. And remember, there's a lot of factors here: processing power, bandwidth, but we are using the same Pi 0 on all these tests. The location doesn't change and the same power supply. So hopefully there will be some sort of difference. Same upload test with the A1 card, same G-code file. And here's the results for our A1 card. Unfortunately, pretty much no difference. The extra write speed didn't help us at all with uploading that file. But let's do the slowest card that we tested in the bunch, just to make sure it's not going to make any difference at all. And here we go with our final upload test. So on the upload test for this card, it actually was just a little bit slower, but only by 20 seconds or so. Is it because the card's slower? Maybe, but I don't really think it's enough to decide either way. And just for a refresher, here are all the stats again for all those cards, so you can kind of compare them, but so far we really haven't seen a difference. So on the original Pi 0, the speed of the SD card doesn't really seem to matter much. It's not the bottleneck here. It's the processor that the Pi 0 uses. It doesn't have a whole lot of horsepower. But that leads me to another question. If we had more processing power, would that move this bottleneck? And then the SD card speed would come into play. So that's what I wanted to test next. And remember, my performance is based on experience. Is it faster to use? Is it easier to work with by using a faster SD card? That's what I'm trying to find out. And just to confirm, the Raspberry Pi we're going to be using for the next round of tests, just to give it a little more horsepower, is the Raspberry Pi Zero 2. So now that we're switching to the Zero 2, I'm going to go ahead and rewrite an image on all of these SD cards, just in case all of the restarts and tests we did corrupted them somehow. I want to be able to give it a fresh start. So I'm going to rewrite these 3 cards we tested, and then we'll start our testing again. Now that we've put a new image on all of our cards, let's start with the more cost-effective, slower model, and just see how it improves on the Zero 2. Now, if you've ever had the pleasure of diagnosing a performance problem on anything technical, sometimes we call that just moving the bottleneck. Is it the processor that's making this faster, or the fact that it can process faster with faster media? So that's what we're actually testing here. So let's start with the reboot test and see where we go. So a definite vast improvement over the original Zero at 1:20 for boot time, even on the lower end card. Let's go ahead and test that upload again as well. Upload time 1:35. So really not much different from the other Pi 0 versus the Zero 2. Let's move on to the A1 card and see if the processor versus the card speed helps out any. And here we'll start our reboot test on our A1 card. Reboot. Reboot time on the A1 card was 1:11. Go ahead and try the upload while we're here. Upload time on the A1 card, 1:37. So upload time, no improvement, maybe a little improvement on the boot time, but not really enough to tell in between the 2 cards. So now let's move to the Extreme card, see if we can get any benefit from that. Onto the Extreme card, we'll go ahead and start our reboot test. And our Extreme card boot time was 1:05. Let's go ahead and run that upload test while we're here. Upload time on the Extreme card was 1:22. So the Extreme card might be just a little bit faster on boot. In succession, they were just a little bit quicker, but only by a couple of seconds. So honestly, on the Zero 2 with the extra processing power, there's pretty much no difference in between all of these cards. Even given all the different performance stats we saw and how different they pretty much perform the same. So obviously the Zero 2 is a vast improvement over the original. Just the whole experience is better because it has more processing power. But as far as the speed of the SD card goes, it really doesn't matter that much. Maybe just a little bit, but honestly, if you're going to buy a more high-end card, the reliability is probably the factor that you're going to want when doing something like this with a Raspberry Pi. It's just not going to be that effective to go with a faster card. But I did want to keep testing just a little bit more. So I brought out just a little bigger Raspberry Pi. I do have a Pi 4 that has 8 gig of memory. Would it make a difference? So here's my Raspberry Pi 4. Again, it does have 8 gig of memory. I'm just going to run one test with this Extreme card. Does it make a difference over the 02? So here we go. One final test on our Pi 4. I created a brand new image for the Pi 4. We're just going to try the reboot test. And we got the reboot done in 53 seconds. So it's a little better, but really only by about 20 seconds or so. I'm not expecting a miracle here, but I do think it's interesting to compare the different platforms. And let's go ahead and hit that upload just for fun. And the upload time on this one is very impressive. It's actually at 26 seconds. But that's probably due to the better Wi-Fi connection, honestly. But the difference did make me want to test one of the other cards one more time. So I had to give it a try. We're back with our lower speed card. We're going to try the reboot test on our Pi 4. And we came in at 58 seconds, so not too bad, but not really all that far off from the Extreme card. And let's kick off our upload. 1 minute and 9 seconds. So we have finally seen a difference in between write speeds on these SD cards. The Extreme card was much faster when uploading a file. So the Pi 4 had enough processing power to actually make a difference as far as the media goes. So what have we actually learned here? Well, it really doesn't matter that much which SD card you use, as far as OctoPrint is concerned. And the 02 is more than enough power to run OctoPrint. If you have a Raspberry Pi 4, it's probably overkill, and you could use that for different projects. But the Extreme card, just because there's not a lot of difference in between price, they're really designed for doing things like 4K video. But the fact that you can write the image so much faster, it was around 1.5 minutes versus 7 minutes on the slower card, that would be worth it to me. So you will get just a little bit of a performance bump, depending on which Pi you're going to use, but probably a waste of that high-speed SD card as well. Just grab one that's somewhat quality, that will give you some sort of reliability. That will be it for today. Hopefully you found this interesting, and I'll see you really soon on the next one.